believe it or not, but we have 5 billion cell phone subscribers today. And the majority of these, close to 60%, are actually being used in developing parts of the world. So in Africa, for instance, you cannot find proper roads, but you will definitely find reception. And if you look at that existing infrastructure in terms of connectivity, in terms of the cell phone's hardware and software, it holds a significant promise to be utilized not only just for talking, but also for health monitoring purposes. So what we're trying to do is we use the cell phone as a platform for monitoring these challenging tasks that we have, especially for remote locations, such as infectious diseases. Imagine that your cell phone, for instance, is attached to a small cost-effective unit that runs at the back of the cell phone to look at blood smears. Then you would potentially have the imaging ability to look for blood cells that are deformed by parasites, like malaria parasites. And this could really lead to diagnosis of malaria in very remote locations. Every few months, we have to count the patient's CD4 density, and that's very difficult to do with these giant machines that we have because they're not portable, and more importantly, running costs of these machines are very high. Per test, it would be costing $10, around $10, which is not affordable, of course, for African standards. So that's why we've developed some technologies which combine some nanotechnology with lens-free microscopic imaging, where we were able to count CD4 or other populations of lymphocytes on spatial microfluidic devices, so that from their shadows we were able to count these cell types for HIV-positive patients with a nice accuracy, of course, much more compact and inexpensive than a conventional